let's do some guided practice. Same thing as always. Start with the trig function. Now note that I didn't include the coefficient here. You could if you wanted to. You could if you wanted to. There's nothing saying you can't. But just note that that means that you need to multiply by 3 to begin with, right? So if you want to start at this step, then that's fine. Right? Because multiplying a function by a number does affect its amplitude, right? It stretches it out vertically, okay? So that does matter. Right? And then, right, we could just add 5 to both sides, or to all 3 sides, I guess. So we get that. And then divide by 2x. Right? And then at this point, well, does this really work? Let's take a look. The limit as x approaches infinity of 2 over 2x equals limit as x approaches infinity of 1 over x, which equals 0. So maybe I could say since this guy equals 0, which I think you can also just see. I'm hoping you can see this. Limit as x approaches 0 of 8 over 2x by the squeeze theorem. We have that the limit as x approaches infinity of this lovely thing right here equals 0 as well. Okay. And maybe I'll move this over. I don't want to look it up with the next problem. There you go. Next up, similar sort of thing, right? So we're going to note that cosine is between -1 and 1. So that means that, yeah, I guess I'll put it over here, right? -4 is less than or equal to -4 cosine of x, less than or equal to 4. All right, multiplied everything by 4, -4. Now, -4, right, oh, technically speaking, it would be 4 on the left side, -4 on the right. That wouldn't make sense, right? It's inequalities. You have to flop it. 4 can't be less than something and less than -4, right? So make sure to flop those, right? So anyway, we have this. Bust out some implies symbols. Here we're going to add x cubed to all 3 sides. Divided by 2x cubed plus 1 to all 3 sides. And we're looking pretty good here, right? Do you see what the limits are going to be? Right? Since the limit as x approaches infinity of -4 plus x cubed over 2x cubed plus 1. Well, again, we need to kind of knock that down. Be a little careful with that. Right? That's going to wind up equaling -4 over x cubed plus 1 over 2 plus 1 over x cubed. And that winds up equaling 1/2. Right, and I'll let you verify this, but that is the same as the limit of this guy. Being a little lazy and not doing this, but I'm leaving it to you to do it. And by the squeeze theorem, limit as x approaches infinity of the original expression. It's a lot of writing sometimes, but do you notice that the problem-solving process is just exactly the same every time? Oh, actually, no, it doesn't equal 0. It equals 1/2, right? And maybe you could have noticed that because of the coefficients are 1 and 2, right? The cosine term is negligible in size, but its variation, right, its oscillation did cause some problems and required us to use the squeeze theorem. Okay? And then last but not least, we've got this guy, right? So in this case, same thing, right? Just note that cosine of 5x is between -1 and 1. So if we just, you can multiply by e to the negative x. I think it's probably easier just to divide by e to the x, to be honest. Right, and sure enough, since limit as x approaches infinity, I think this is pretty clear. You can kind of do this in one shot, no steps really required. By the squeeze theorem, we have the following, right? We have that the limit as x approaches infinity of so you can write it as e to the negative. I want to keep the notation similar to what we had in the problem-solving process. That equals 0. So I do it.